Hello everybody, I hope you're all doing well and you're ready for more of our grade 8 Gauss contest. We're up to question number 23, so that's what we're going to be taking a look at in this video here. Okay, so question 23, if n is a positive integer, the notation n factorial, which comes up a lot in future math classes and math contests, so it's something to maybe play around with if you've never seen this before. It's used to represent the product of integers from 1 to n inclusive. For example, 5 factorial is 1 times 2 times 3 times 4 times 5, which happens to be 120. A quick calculator check will verify that. Okay? Which of the following is equal to a perfect square? Now, a quick note about these factorials. They come up, I teach a first-year math course at university, and we use factorials a ton. This is about counting problems, this particular course. And factorials are a great counting expression, I guess we could say. Factorials allow you to count the number of ways to order things in a line. So if I have 3 things, A, B, and C, 3 factorial is the number of ways to actually write them out in a particular order. A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. These are the only sort of arrangements, call them linear permutations, of these 3, and there's 6 of them, and you'll notice 3 times 2 times 1 is 6. If I had 5 things, it would turn out there's 120 ways, but we don't want to write them all out, so this is what the factorial notation actually does for us. Now, we don't need that for this question. I just thought I'd mention it because, you know, factorials are a good thing to know. They're good to know for contests. They do pop up more than just this contest, and they're also good when you hit late high school, early university. Okay, they're fantastic for counting problems, so there's something to watch out for. Okay, but let's take a look at the various expressions. We want to know which one's a perfect square. So on the top, we always have 20 factorial, 19 factorial, and then it's just a question of are we divided by 1, 2, 3, 4, or 5. That's it. Okay. Now we're going to use I think a great little sort of trick. I'll show you this trick. I show my students this trick as well. It doesn't sink in with them. Hopefully you're a little bit smarter than a first-year math student, and it'll sink in for you. So if you take any factorial, you're just going to take the number, multiply by the net, one less, one less, one less. Or I guess the way they're writing it out, they start with 1. It doesn't really matter. Okay. What did they say? Brought in the numbers 1 to n inclusive, so they went 1, 2, 3, 4, 5, so we'll write it that way. But you would keep going all the way up to n minus 1, all the way up to n. Actually, we'll add in a few more terms. And you just count all the way up to n, right? Now, this expression here, what is this? Do you recognize it? Do you recognize 1 times 2 times 3 times 4 all the way up to n minus 1? So without this little n over here. And you might not. But this is the product of the numbers from 1 to n minus 1 inclusive. Every number's there. And we have a brand new name for that. It's factorial. So this is really n minus 1 factorial. Okay? So n factorial is n minus 1 factorial just times an n. We can see this with our 5 factorial. Take the 5 away, and what are we left with? 1 times 2 times 3 times 4? Well, this is the product of all the numbers from 1 to 4 inclusive, which is 4 factorial. Right? So this is a nice little trick. Now, why do I bring this up? Well, on the top for every single expression, we've got 20 factorial times 19 factorial. Times 19 factorial. Okay? Now, if we're looking for perfect squares, we might try to match things up. So watch what happens. 20 factorial, I'm going to write it as 20 times 19 factorial. Okay? Pull out the 20. And what have I got? 19 factorial times 19 factorial? That's 19 factorial squared. So we've got 20 times a perfect square. And you know what? 20 is 5 times 2 squared. So the top, because it was that over some number, is 5 times a perfect square. If we divide by 1, well, we're not going to have a perfect square. If we divide by 2, if we divide by 3. But if we divide by 5, which I think was the last one, we will cancel out this 5, and we will be left with a perfect square. Right? So even though your calculator might do 20 factorial or 19 factorial, but I very much doubt it's going to list all the digits. And so it'll cut it off at some point. So you can't easily do calculations on your calculator with it. But if we sort of play around with our definition of factorial, we pull out this 20 and group things together and realize, okay, the 19 should pair together, the 18 should pair together, we can get squares this way. And it's very easy to see, all right, just get rid of that 5. Get rid of the 5 and you'll be fine. We can see E should really be our answer for this question. Okay. And there we go. Nice little factorial question. Just in general, if you have any factorial questions, by all means, ask them down below. I'm more than happy to talk about them. Some of it might be a little more advanced for you. This is a grade 8 contest after all. But if you're interested in it and you want to know a little more advanced math, feel free to ask me questions about factorials there. Okay? But I'm going to continue on to question number 24, and I'll see you for that next time.